Hi guys, so I suggest that we get started. Hi everyone. My name is Doron. I'm from Red Hat. I'm leading the SLA and scheduling team for the past 2 years. I've been in Red Hat for 5 years. And we're going to talk today about hosted engine, or as we call it, the chicken and the egg, and we'll soon understand why. These are the things that we're going to cover. And if you have any questions, we'll take it at the end. So let's start. The main thing I would start with regards to hosted engine is the fundamental question. The fundamental question for us was, why did the chicken cross the road? This is something we were thinking about. We were trying to understand, why do we need the chicken to cross the road? This is real philosophical stuff, as you probably know. And we didn't, or we couldn't come up with the right answer in that context. So, anyone has an idea? Why did the chicken cross the road? Anyone? Sorry? Nice, but no. Anyone else? Sorry? Okay. So I hope that by the end of this session, we will all be able to answer this question. So with regards to a hosted engine, let's start with understanding what is hosted engine all about. So we would like to use a standard oVirt installation, but we need that installation to happen inside a virtual machine. Okay? That virtual machine has to be highly available, so we won't lose it in case of a host crash. The problem is that that VM is managed by the application it is hosting. And that's very challenging. So that's the chicken and the egg problem. And you probably know the drawing. And if you know Azure, there are many more. So that's hosted engine, but why do we really need it? So the answer is very simple. It's all about money. It saves us money. And if you have failover equipment and special equipment, it will save you a lot of money. So that's the reasoning behind it. Okay? But as you know, nothing comes for free. While we were trying to implement that, we were actually looking into some serious challenges. Okay? So to begin with, we had the whole chicken and the egg stuff. How do we end up in a situation that a VM is running an application that is monitoring and controlling that same VM? That's quite a big of a headache, which we had to handle with, and we will soon see how exactly we solved that. So that was the first part. But then, once setup is done, we need to make the VM highly available. We need to make sure that we handle network in case of network connectivity loss, handle all sorts of troubles we have in life, as you probably know. Life is very hard in the data center, so we need to be able to handle unexpected things as much as we can. So load balancing, maintenance, everything we need to do with the standard equipment, we will have to do here, but as you can see, it's a bit more complicated. So when looking at these issues and understanding what's the right or the possible way to do it, we were trying to look for existing solutions. So let's take a look at what we know. So some of you are probably familiar with the VMware's clustering file system. There's only a small problem with that. It's proprietary. We can't really use that. So that's one thing. The other option is we have, at least Red Hat has RHCS, or Red Hat High Availability as it's called today, and there's another option of using Pacemaker. They have a standard file system. They use the CoreSync protocol and library. It's limiting you to a specific amount of nodes. You can't extend beyond that. And there's no real oVirt node support, which is something that we need. Most of our users actually use oVirt nodes. So this is how we started. This is the market or the available solutions as we saw it. And we said, OK, let's try to think a little bit more about that. Okay. let's try to consider a standard file system and not a proprietary one, and go for Sunlock lists. Sunlock, I don't have a special slide on it. Basically, it's a locking mechanism. Okay, it was developed as a part of the oVirt community project. Okay, and it enables us to provide lists for disks or for VM. Okay, so we were saying let's make sure that Sunlock provides us the locking mechanism, and we will work with NFS or other standard file systems. That should bring us into something which is simple enough. Okay, it's open source. Sorry, that should be the first thing. Open source, simple enough. It's focused in virtual machines, so there's not a lot of logic behind it like the other solutions have, because they would like to provide high availability for other resources and entities as well. So that's pretty much focusing in exactly what we need. So it's much simpler. It should be easier to implement. So with this concept in mind, we decided to go and start looking at the architecture. We had several discussions. The architecture at one point was too complicated, so we decided to simplify things and go for a standard 3-layered classic architecture. In every one, you will have the UI, the business logic, and the data layer. So in our case, we have CLI, that's Linux. We have oVirt HA agent, okay, and we'll soon see exactly what each of them is doing. And we have the oVirt HA broker. The broker basically is connecting us to the shared storage. And that's it. Very simple architecture. So let's start diving into it, starting with the CLI. I'm not going to read all of that. That's something you can actually do with the simple minus help. But in general, the CLI is very rich. It gives you the whole VM lifecycles and even more, any storage-related functionality that we need. Let's see, status reports, password changes, anything else. It's very basic, I know, but it's Linux. And it gives you all the functionality that you need in the beginning, including maintenance support, as we will probably cover later on. So nothing really, I mean, it's not rocket science, a very basic CLI, which will give you all the functionality that you need. Moving to the next level, we have the HA agent, okay? Or as we call it, the brain. Basically, that's the component that has the state machines, the logic, everything that is related to high availability. It's a standard system service. Okay, it can crash and burn. We have another one that will make sure that we will handle this situation. Okay, and if something wrong happens to the VM, then that module will take action. Either restart the VM or migrate it or do something else based on the state machine that is relevant to that situation. Okay, in order to get the information and connect to the storage, we have another layer, which is the next one. Data layer, and that's the HA broker. Okay, so the HA broker, or the middleman, is basically an intermediate layer between the logic and the actual data. It's a standalone service, so again, it can crash and burn. We have another one as a backup. Okay, we use shared storage, so this is actually connecting to the storage. It's writing and it's updating and reading from specific areas in the storage. And we will soon see exactly what we're doing in the storage. So that's the storage part. And with regards to monitoring, so it has a very nice pluggable architecture, so you can actually create your own monitoring components. Basically, it's small scripts like a ping script or something else like, I don't know, SNMP. That should report back and give us some sort of indication. So if we want to ping the gateway, for example, we have a very small script that is doing that. It takes as an argument a gateway IP address, and it returns true or false, basically, whether we have a ping to the gateway or not. The same goes for CPU load and 3 others built-in monitors that we have. But going forward, as you can see, this is pluggable, so you can add your own. And one day, we should be able to support other HAVM types. So you can actually have be able to monitor other characteristics or other attributes of the VM based on the VM content. So that's about monitoring. The purpose of monitoring is to be able to provide us the information, and then the logic part, which is the agent, should be able to calculate the situation and understand what should be done. So for that purpose, okay, we made up some sort of a small system that is scoring a host based on the monitoring results that we got. So there's it's a very simple mechanism, which is bitwise, and basically every bit is telling us whether it's a ping issue or a gateway issue or anything else. We end up with a score, and the score represents the host status. So in this way, it's very easy to get a number, and that number represents the host suitability to run a VM, which is highly available, hosted engine in this case. And then all we need to do is compare every two hosts, which is rather simple. The bigger one will be the better one. So that's scoring. Looking into the storage. So the storage is a bit tricky because, as you understand, this is the part where we synchronize all the hosts. All the hosts should be able to read the same information and act upon it, okay? And we should be able to understand what happens if a host disconnects from the storage or crashes or something else happens. Let's say that the services died, for example, okay? So what happens is that we create a special storage domain, okay, in the shared storage. We only create it once during the installation of the first node, okay? That storage domain will end up holding the hosted engine disks, okay, and two specific files. In NFS, it's files. Going forward in other storage types, it will be just areas or blocks, okay? So we have a Sunlock metadata file, and we have the agent metadata file. Currently, we're supporting NFS. That's the first thing that we were able to achieve, but going forward, we will support other types. So this is basically the path where we should find these files, okay? And we have the log space for Sunlock, and we have the metadata for the agent. So Sunlock is pretty simple, I mean, for the Sunlock guys, but for the metadata, this is actually something new, again, that we had to design. So let's take a look at the metadata. It's not very complicated. We're using 4 kilobyte chunks, which is one per host, and the 0-1 is basically cluster level stuff. So the first host will be using the first real chunk. Okay. Yeah, that's pretty much the general file structure. It's not very complicated, but the interesting stuff actually hides inside. So if we will dive to one of them, we will actually see that it's divided into two parts. The first part is 512 512 bytes, and the second part is everything else. The reason why we had to split it is that because atomic write, and we need to make sure that the writes are atomic, okay, can only be achieved at maximum of this size, okay? So the first part, which is the first 512 bytes, simply holds a list of bytes. This is what you will actually see inside the storage if you take a look. And the rest is something which is more human readable. It's for us. So we should be able to debug it, or if something happens, and you can actually retrieve that data and take a look and understand what's going on. For example, we have a very nice timestamp, so you can actually see if the host disconnected or was not connected for a long time. So that could actually be a reason not to use that host or to migrate away a VM from that host. And there are several other things here, such as the score, which is quite explicit, and everything else. So that's what we made sure that the storage will include. We have atomic writes, which means every time the broker will write it, everyone else will be able to read that information. The same information is being read by all the other hosts. So that, in general, is all that we needed. We have a locking system. We have a way to synchronize all the hosts together on shared file system, NFS, and basically that's it. The only thing we're left with now is to solve the whole chicken and egg stuff, which means how do we install a VM with an operating system, with the application, and then control that VM from the application it's hosting. So this is the basic flow. Okay, the first one is a bit long. The second one and later happens much faster. Okay, so we start with the basic setup. Then we run the hosted engine HA, and we have VDSM being installed and create the first and only storage domain we have for high availability. Then we need to start the VM for the first time. It's an empty VM, and the disks are located inside the new storage domain we just created. We are installing the operating system and oVirt, and we need to reboot everything to make sure that it's persistent. And we get, after the reboot, a list lock for that VM on that node, which leads us to a VM running the oVirt engine. Okay? So that will be the flow for the first host. Anything else we'll see is much faster. Basically, we are starting the setup, running the hosted engine HA. VDSM is installed. We are actually be able to detect that that storage domain, this one, already exists. So we will ask the user, hey, is this HA, and you are working on the second node or above, and you will say yes. We will simply copy all the settings from the previous node, and that's it. You're all done. So let's see how it looks like in real life. I'm not doing any live demos here because, as you all know, the network here is the best effort one, so I'm not taking the risk. So it's not going to look very good, so I used my amazing graphic support. Still doesn't look very good, but in general, this is how we start. We run the setup. It's telling us that it's about to start to create a VM, do everything needed, have a lot of stuff running here. And then we're being asked for the storage configuration. We should give the shared storage path. Okay. As you can see, we're planning for Gluster, and there's more coming. This is quite an advanced stuff for my debugging system. Okay. Then we will continue to network configuration. What is VM configuration? We can decide how much memory we want, what kind of CPU, how many CPUs, and we end with with the hosted engine configuration itself. Basically, we are asked for the ID of the first host, which by default is 1. Okay, some other relevant information like password and so on and so forth. And then it will keep running until it will finish everything. It will create the VM for the first time, and it will provide us a way to connect into that VM. And as we remember from the flowchart, we now need to install the operating system. So we install the operating system, we reboot. The VM is automatically created again for us with the operating system now. And we are being asked to install oVirt engine inside. This is running through, and that's basically the end. The HA services are being enabled, and everything is restarted to get locks again officially. And we have hosted engine successfully set up on the first node. That's what you'll see when you browse into the administrator portal. So if you'll go to the hosts tab, you indeed will see the first host that we managed to install. Okay, that's the first node. And if you will go to the virtual machines tab, you will be able to see all the details of the virtual machine. So we have hosted engine alive. Okay. The next task will be to come up with a second node or more. And that, as I said, is much simpler. And without that, we don't really have high availability. So we simply run a deploy. We can provide an answer file, but if we won't provide that, once we will understand that there is already a storage domain for hosted engine, then we will ask you to be able to SSH into that machine, and we will automatically use SCP to copy all the relevant settings from the second node or more, and we will only ask you for an ID for the new node that you just created. Default is 2 in this case. And basically, that's it. You can go into the administrator portal. We will tell you, you have another one set up, and this is what you'll see. We have 2 hosts running now. Okay, this is after some plays, but this is the hosted engine itself. And now we have 2 nodes covering for the hosted engine, so if one of them crashes, it will be good. It will be resumed or restarted somewhere else automatically. Even if the host doesn't crash and we only lose the network or storage or something like that, then we will be able to migrate or resume to another host. So that's basically the whole setup part, which gives us this very nice picture. If we want to try some simulations, okay, as I said, this is all something I already made for you. So this is a report you get from a status query in the host level. So the first host is called hosted engine 2, and you can see that in this case we have the VM in an up state, we have a good health status, we have the maximum score, and the gateway is fine. On the second host, the VM is down because it's running here, okay, and we also have the perfect score of 2,400, and the gateway is down. In order to test it, okay, I blocked the gateway in hosted engine 2, which is where the hosted engine VM is running. So this is what we're going to see. So the VM was running here. That's the host, okay? If you take a look at the virtual machines, you'll see that there's one VM migrating. It's actually migrating away from here and into here, okay? If you think about it, the VM is running the engine, and it's live migrating itself. So what you see here is while live migration is happening, which is quite amazing. And that's the VM itself. You can see the status is migrating from, okay? And it's currently running on engine 2, but it will move to hosted engine 3 eventually. So that's how it looks like, and that's the expected result. And this is what will happen when we'll see the report. You can go in and see that the gateway is not pingable, basically. And that's why we reduced the score, and that's resulted with the live migration of the hosted engine VM itself. And here, everything is fine, and the VM is up. So basically, that's it, okay? We can return to the fundamental question of why did the chicken cross the road? Any answers? Could have been the gateway. Almost. From what we tested, it didn't cross the road, it was migrated. That's it. Questions? Yeah.
Let's assume you have 10 hosts. Do you need to run the engine setup on every host?
No, that's exactly what I showed. You need to run just 2 or 3 or something like that. Yeah, you need to run the hosted engine setup, but it will automatically vacuum all the settings from the first one. So it will only ask you what's the ID, basically, and that's it, and you're all set. So the long installation only happens for the first time because we have the whole chicken stuff. But once you're through, it's very fast.
And then I have another question. Is it possible to install the operating system of the hosted engine by Pixie boot?
Okay, the question was whether it's possible to install the operating system of the hosted engine via Pixie boot, and the answer is yeah, definitely yes. Yeah.
How far is the cluster FS port?
Sorry, can you repeat the question?
The cluster
Yeah.
It's still in planning phase or already in development phase?
Which cluster FS?
Sorry, the storage side.
Yeah.
The plan is you support now NFS.
Right.
But we are trying to support cluster as well, cluster FS.
Oh, cluster. I heard cluster. Sorry. So let me just repeat the question. The question is, I now understand, is how far away is the cluster support? So in general, what we did here during the implementation is that we use standard VDSM libraries. We are working with VDSM to create and maintain the storage parts of hosted engine. And since VDSM is already supporting everything, in general, it shouldn't be that difficult. We are now trying to, sorry. In general, we are now trying to make it work. So, yeah, not a good idea. Let me run through this. It's a nice recap. Yeah, another one. Almost done. So since we're using VDSM libraries, we don't have a lot of, the gap is not that big, but we have to test it, okay? So actually, Gluster should come up in the near future with like bare metal Gluster support or something like that. So we're considering of, taking advantage of that. But in general, for SUN and block devices, we're now testing it, and I hope that we won't have a lot of mileage to do. So I would expect that to come in any of the coming next versions. I'm not sure if it's, well, it's not 3.4, but probably 3.5.
Is SEP also on the list?
Okay, the question is SEP also on the list? So I was, previously I was telling you about one of the solutions we saw was pacemaker. So yeah, it's either SEP or pacemaker. We're still considering that, in the next major version, we may want to consider again SEP or pacemaker. So we're not ruling out that completely. It may still work for us, but we need some mileage to work with hosted engine. Again, it's like a new technology for everyone here. So we need to make sure that it's completely reliable. And then if we can improve that by integrating with something like SEP or pacemaker, then of course it would be very nice. More questions? Okay, thank you very much.